Now let us understand the electronic configuration in the position of an element in the periodic table. As we know that the nucleus, center of the atom, contains the protons, positively charged, and the neutrons, no charge. The outermost regions of the atom are called electron shells and contain the electrons negatively charged. The number of protons in an atom is called its atomic number, while the sum of its protons and neutrons is called its atomic mass number, which is represented by a besides protons and neutrons. There are negatively charged particles, called electrons, which revolve around the nucleus in various shells or orbits. This arrangement of electrons around the nucleus of an atom in various orbits is called its electronic configuration. We need to understand here that the number of electrons in an atom is always equal to the number of protons, which makes the atom electrically neutral. Every orbit has a certain capacity to accommodate electrons. The maximum number of electrons that can be accommodated in a particular orbit is determined by the formula 2n squared, where n denotes the orbit number. The first orbit n is equal to 1, therefore 2n square is equal to 2. Hence, the maximum number of electrons that can be accommodated in the first orbit or K shell is 2. Similarly, for the second orbit n is equal to 2, 2n square equals to 8. It means 2 2s are 4, 4 2s are 8. Hence, the maximum number of electrons that can be accommodated in the second orbit or else shell is 8. Although, the third orbit can be occupied by maximum of 18 electrons. For example, the atomic number of sodium is 11. Therefore, there are 11 electrons revolving around the sodium nucleus. In the sodium atom, out of these 2 electrons enter the first orbit K shell, 8 in the second orbit that is L shell, and the other 1 electron enter the third orbit that is M shell. The electronic configuration of sodium is 2, 8 and 1. The electronic configuration of an element also helps us to decide the position of an element in a periodic table. The number of orbits or shells denote the period to which that element belongs to it. Let's continue with the same example of sodium. Its electronic configuration is 2, 8, 1. This means there are 3 shells in an atom of sodium, and therefore, it belongs to the third period of the modern periodic table. Similarly, potassium with 4 shells belongs to the fourth period. Lithium with 2 shells belongs to the second period. Rubidium with 5 shells is placed in the fifth period, and so on. The number of electrons present in the outermost or valence shell of an atom decides the group number of that element. Thus, sodium, potassium, lithium, rubidium, with one valence electron, fits into group 1 of the modern periodic table. Magnesium, with two valence electrons, is placed in group 2. Aluminium, with three valence electrons, belongs to group 3. And silicon, with four valence electrons, belongs to group 4. And phosphorus, with 5 valence electrons, belongs to group 5. And so on.